Here are your solutions to section 4-4, linear functions, the guided practice. First problem says simply to graph each function. So again, we could make a function table here. If that's what works for you, go ahead and make a function table. Put it over here. We would have an input of x and output of y. We have a rule of x plus 5. If we put in 0, that's 0 plus 5 would be 5. If we put in 3, that'd be 3 plus 5. That would be 8. I think an easier way to look at this would be to recognize that we have a y-intercept of 5. So we're going to put 1, 2, 3, 4, 5, put our point at 5, and we have a slope of 1 over 1. So we can rise 1, run 1. So we're going to go right through these points here, and I'll make sure that that one shows up. I can do the same thing moving in this direction, which would put a point way out here, and then we can graph and make sure that our graph line goes right through each of those intersections, and it does indeed. And the last thing we need to do is say that this is y equals x plus 5. Again, we could go and check this point here. We have 3, 8. We could check it here. From x, we're going to go 1, 2, 3, and we're up 1, 2, 3, 4, 5, 6, 7, 8. It is indeed 3, 8. For the next one, I'm not going to make a function table because I really would like you to be very, very, very good at this y equals mx plus b format. That's why we spent so much time on it last chapter. So immediately we're going to go to -2, place a point, and then we're going to use our slope of 3x, which is of course 3 over 1, which means we're going to rise 3, run 1, rise 3, run 1, puts a point there. And if we, instead of rising 3, drop 3 and go to the opposite direction, that would put us here. And now we can put a nice straight line on this right through each of these intersections at 3, every 3 units, and there we go. And then of course lastly we need to write y equals 3x minus 2. So that's problems 1 and 2. Problem number 3. We have a satellite company, cable company, charges an installation fee of $50 plus an additional $3.95 per month. Key words here are per month. So that should tell us that that's going to be our slope. So we need to write a function to represent the total cost of any number of months of service. So months is clearly our input, so let's label this. And our output is going to be cost, so we'll use C. So we've got C, our cost equals 35 and 95 100ths times our months, but we also have an installation fee. No matter how many months we pay for, we're going to pay for an installation fee. So we have to add that 50. This becomes our y-intercept, that's B. This is our slope, that's M. Okay, so our rule here would be 35.95 plus 50 equals C. Now this is going to start to get to be difficult to see here, but it asks us to plot 1, 2, 3, 4, and 5 months, and then to graph that function, and then ask is it continuous or discrete. Well, this is pretty easy to do. We just plug this in. 1 times 35 and 95 100ths plus 50 would be 85 and 95 100ths. But again, we're going to have difficulty seeing this, so I'm going to do it the easy way. Turn the answers on, and now continue to explain. So one thing I'd like to point out is notice that they said that it was 50 plus 35 and 95 100ths M rather than reversing those two. I reversed them for the simple fact that I want you to get used to y equals mx plus b format, but this is the very same thing. If we put our inputs of 1, 2, 3, 4, 5 in, we multiply the 35 and 95 100ths by 1 in this case, 2 in this case, etc. We always add 50, and we end up with these values here. and now we're going to graph these. Well, our input was months, so that has to go on the x-axis, and our output was cost in dollars, that has to go on the y-axis. So when we start plotting this, we're going to plot 1 and 85 and 95 100ths. 1, 85 and 95 100ths is right here. Just randomly, I'll pick up another couple of points. We're going to plot 3 and 157 and 85 100ths, 3 and 157 85 100ths, and 5 and 229 and 75 100ths. 5 and up to 229 would be right about here. So there we go. Now, we also need to, so we graph the function. We also need to determine, is this continuous or is this discrete data? And this situation is discrete because you cannot pay for a partial month of service. Now, I know that somebody out there is going to probably point out that if you move or something at the end of the month, the cable company will only charge you for the half month you used. That's really not what we're looking at here. You can't call up the cable company every month and just get the first half of the month cable service and then turn it off for the second half of the month. They're never going to allow that. You need to pay for whole months in every case. In fact, even if you move, my suspicion is they would not give you money back. So this is indeed discrete data. It's going to be in multiples of 35 and 95 100ths, plus, of course, that y-intercept of 50. Now, the last thing that it says is interpret those points graphed. Well, we have these points right here. We have the point 1 and 85.95. So 1 month costs $85.95. 2 months costs $121.90, etc., etc. I'm just going to leave the answers on and go to the building on the essential question. How can functions be used to solve real-world problems? Explain. Well, for example, a function can be used to model a real-world situation in which the data is discrete or continuous. It's very powerful for you to recognize that we could take a real-world situation like this cable situation and put it in an equation and then solve any number of months in that equation very quickly and efficiently. That is exactly what functions are all about. Please do independent practice.